Hi, everybody. Today, what we need to do is talk about galactic motion. So, let me get started here with it. The first thing we need to do is talk about what is at the center of the entire galaxy that we live in, the Milky Way. Right. So, here's a picture. This is actually from Hawaii, where you're looking at the Milky Way. This is what the night sky looks like if there's not all the light pollution, like your neighbor's porch light and truck stops and highways and warehouses and stuff like that that light up the night. Well, if it was dark enough, you could actually see the Milky Way. You could actually see stars, right? And for a very long time, people have wondered what's at the very center of, oh, there we go, the Milky Way. Get it? Milky Way. Um, so the first thing is, if you look at the Milky Way at the very center of it, right, you can see the center of it because there is a constellation called Cygnus, or often called the Northern Cross, because it kind of looks like a cross at the same time. If you can find Cygnus or the Northern Cross, you're pretty much looking directly at the very center of, where'd my picture go, of the Milky Way. So you're looking, right in, this kind of area right here for the Milky Way. Right? Remember, the Milky Way, it's kind of like a big disk, and when you're looking at the Milky Way, it's kind of like you're looking across the disk. You're looking in towards the center of the galaxy, right? And so that's kind of the shape that you see right there and everything. So, oh, there you go. So there's Cygnus and everything. It's supposed to be a swan, I guess, or a goose or something like that. Some kind of big bird is what they, ancient people saw when they looked up at that. Right, so and there you go. The Northern Cross is the other thing that they often call it. Right, and so here you can see here's like a picture of the Milky Way. You can kind of see lightly in the background, and it's kind of cool because that Northern Cross or Cygnus, it kind of goes like right across just about where the very center of the Milky Way is. Right, for it. Vega is another pretty bright star in the night sky. So if you can find that, that's pretty close to the center of the galaxy for it. So here you go. Here, same thing. Here's a picture of the Milky Way and about where Cygnus is going to be. Here's a cool picture. This one actually, it's made up of a series of images that they've taken of basically pointing the camera straight at the center of the galaxy and what it looks like, right? But it's taken with different types of instruments. So first is this one right here. Here's an optical image of the center of the galaxy. So it's just like a photograph. But look, here's it is with X-rays. Here it is with gamma rays, right? Infrared waves, different kinds of infrared waves. Here's like a hydrogen counts and everything. Radio waves, atomic hydrogen, more radio waves. And so what they can do is they've taken all of these images and they're able to kind of composite them to see what does the center of the galaxy look like. All right, for a long time, astronomers have kind of wondered what it looked like that's in there. Here's a cool picture. Here's an actual computer image of the very center of our galaxy, right? Would be right here at the very center of it and everything. And what's cool about this picture is each one of these little circles that are kind of spinning around in 3 dimensions, that's a star. Like here's the star right here. And that's the trek that the star takes in just a couple days, right? This is a really, really, pretty short time span here and everything. And so scientists have kind of wondered also, okay, we can finally see, we have enough technology, enough telescopes focused on the center of the galaxy that we can see there's several stars, there's about 20 of them, and they're all whipping around in these tiny, tight little circles, and which is weird. I mean, they're entire stars. I mean, imagine our entire star, and it's just every day or two, just whipping around in this big circle. Right? What is so strong that it's got enough gravity to actually do that, just kind of play with stars like they're tiny little toys? And the answer is a black hole. Oh my gosh, you mean there's a black hole at the center of our entire galaxy? Yes, there is. In fact, they've named it Sagittarius A, if I'm pronouncing that right. That's what's at the center of our galaxy. And it turns out it's a good thing, right? There's enough gravity there that's holding on to stuff that's why our galaxy keeps spinning and staying together, right? If there's not a black hole, if there's not something super, super massive at the very center, everything just kind of flies away into space and our entire galaxy falls apart. So it turns out it's a really, really good thing that, our black hole is there, at the center of our galaxy, kind of holding things together. So it's kind of a cool picture. Here again, here's a picture of the Milky Way. Some places are really bright because there's tons and tons of stars packed in there. The part that's kind of dark as it kind of goes through, that's just because there's also a lot of gas, dust, and rocks and things like that in, towards the center of our galaxy too, all being held there by that big black hole. And so it just means there's more stuff there. It's not like there are no stars towards the very center of the galaxy. There's just more stuff in between us and where that actual, edge of the galaxy is, right? So that's our Milky Way. It's going, remember, it's spinning, right? It's spinning really, really fast. I mean, just incredibly fast that it's spinning from it, from our standpoint. And from where we are, when you look at it, that's where that Cygnus comes in, or, the Northern Cross, right? That's, what we're looking at. That's where the center of the Milky Way is. It's at the end. Oh, there you go. There's the black hole. Let's see here. Oh, so what is a black hole? Since we're talking about it, it's not actually a hole in any way. It's actually, think about it like it's a sphere, and it's just so densely packed together. This stuff is so tightly held together that it's got so much mass that anything that gets even slightly close to it, it's got so much gravity, it pulls on it really, really strong. Kind of like if you're floating in space and you come by a planet, right? The gravity's planet pulls you in. It's just like that, but much, much more dense. So it's much, much stronger. It's so strong, in fact, that even if there's a light particle flying by the black hole, it too gets sucked in, which is what they're kind of trying to show you in this little funny animation right here and everything, is even light gets sucked into it. So if you look at the black hole, it just literally looks like a black spot right there. I mean, you can't even see anything at all from it because all the light gets pulled in too. And that's where the name black hole comes from. But it's not actually a hole, in space and everything for us. Right, so, so we've got that, our definition of a galaxy, right? Yes, there's tons and tons of stars, but it's really everything that's in there. It's rocks and dust and gas and things like that, all kind of mixed together. And there are tons and tons of different ones. I mean, there's just literally countless galaxies out there. Pretty much anywhere we point a telescope out into space, there's tons of galaxies, in that area. And you can see they're all different shapes and colors and sizes and everything like that for it. So, there's lots of them out there. Okay, so that kind of gets us to what we want to talk about right now is the motion. You've got this motion of our galaxy as our entire Milky Way spinning, right? It's going really, really fast. I mean, it's just, incredible speeds and everything like that as it's spinning around. Right, and you can look into the center of the galaxy, and that's where that black hole is, and that's where Cygnus or the Northern Cross. That's what from our vantage point, what we're looking at. All right, hope this helps you out. Take the quiz at the end.